Thank you, Kara. So as Kara mentioned, my name is Tim McCamey. I've been here with the gang about going on 9 years now, and my specialty tends to be in system development and products associated with it. Today we'll be talking about Rational Rhapsody and Rational Rhapsody Design Manager and how they play into really any systems development, but we're going to have a little bit of a focus on medical device, obviously, since that's what the web series is about. So our agenda, go over kind of medical device environment development issues. If you're in that industry, you're probably pretty familiar with them. If not, it'll help set the stage for the rest of the presentation. Move on into model-based systems engineering and SysML, what they are, a quick overview of SysML if you're not familiar with it. And then we'll get into the heart of the matter, which is using Rhapsody and Design Manager for medical device development, again, applicable to a lot of different systems development. In the end, we'll wrap it up with a summary and questions, and that will be it. Okay, so it's no shock that embedded technology is rapidly controlling everything, from your iPhone to your watch to certainly your vehicle. The products that we build are no longer driven solely by the physical piece. Had a car 40 years ago, it really had no electronics in it, except maybe a couple of transistors in the radio. Today, there are 30 or 40 computers in every vehicle produced, even for the more simpler ones. So it takes more than just simple hardware to create a useful device. Hardware, software, and electronics combine to make the product unique, provide the value, and, of course, generate the profit. The products, as a result of the complexity, products are really no longer simple to develop. Complexity is a factor in certain industries, for example, medical device and aerospace. Regulatory compliance starts to be the driving factor in complexity and project time, the amount it takes. Yeah. Okay, so medical device industry adds several unique facets to system development. I'm not sure that medical device adds the extreme trying to market pressures because every industry pretty much feels that. But it pays to be the first person in the market with a new innovative device. You capture the market share and essentially become the leader in that device type. Strict regulations. FDA, Food and Drug Administration in the United States, IEC, many smaller groups throughout the world. Maybe building the same device, automatic defibrillator, for example. You want to sell it in the United States, in Canada, in France, in Thailand, name it. Each of those areas is probably going to have a different set of regulatory issues that you're going to have to deal with and prove that you have satisfied. So you may have many variants of the same product. Fundamentally, it does the same thing, but the way it's actually built, software is written, for example, changes from region to region. Defects are very costly to handle. A little italicized thing here says basically you want to avoid warning letters and recalls, but I mean, let's face it, in the medical device industry, you want to avoid killing somebody, which is a very bad thing to do with a medical device product. These days, almost any type of system is developed in a geographically distributed way. I did some work for General Motors a few years ago, and they were designing around the clock. There was obviously people in the Detroit area, there were people in Germany, there were people in India, there were people